Okay, in section 4.2, we're going to talk about the area between two curves and applications. In section 13.4, we use the definite integral to actually go through and calculate the area between the graph of a function and the x-axis. Now what we're going to do is we're going to do a little bit more work, and we're going to use it to calculate it, being the definite integral, to calculate the area between two graphs. So you need to know this information. Let's start. Area between two graphs. Suppose that f of x is greater than or equal to g of x for all x in the closed interval ab, so that the graph of f does not move below that of g. Then the area of the region between the graphs of f and g and between x equals a and x equals b is given by the integral from a to b of f of x minus g of x dx. Okay, that's how you find the area between two graphs. So to interpret it in terms of the graph, suppose f of x is greater than or equal to g of x. Graphically, this means you have like a function like so. Call that f of x, and then possibly you have a function like this. You can call this y equals g of x, and then you have f of x is greater than or equal to g of x, and then it says then the area of the region between the graphs of f and g and between x equals a and x equals b. So if we draw this line, that's x equals a, it's equals there, and say here, that's x equals b, and this area here, or this shaded yellow part, that's going to be the area that we want to find. So one thing to note that we always, it's an E, we always take the integral of f of x minus g of x dx with f of x greater than or equal to g of x. Okay? If you reverse the order, you will get the negative of that integral. And then take the absolute value. Okay, so now that we know what we're going to be doing whenever we're finding the area between two graphs, let's actually look at a few examples. The first example, we want to find the area of the indicated region. We want to graph the curves to check whether one is above the other or whether they cross. Okay, so we want to find the area that's between the curve y equals x cubed and y equals -1 for all x in the closed interval -1 to 1. So let's sketch a graph. So we want to graph y equals x cubed. So this is y equals x cubed. And we also want to graph y equals -1. Okay, so we also want y equals -1. Let's use a different color. So that's y equals -1. And then we want to have that also bounded by x equals -1 and x equals 1. So let's use another color. Hopefully we don't run out of colors. So we want x equals -1. So let's say that's x equals -1. And then we want x equals 1. So we have x equals 1 here, and we want to find the following area bounded by all of those curves. So we want this shaded area here, and we also want this area here. Okay, so that's what we want to find. Okay, so note that this point, I'll mark this point here, that's 1 and 1, and then this point here, that's -1. Okay, so if we have 2, we get 8. You plug that into y equals x cubed, and if you have -2 down here, then you would have, well, let's make that let's exaggerate a little bit more. If we have -2 here, then this would be -8. Okay, so there you go. We want to find the yellow portion. So the area is going to be equal to the integral from -1 to 1. Now, we need to make sure we take the function that is above, that's the y equals x cubed, and subtract the one that's below it. That's y equals -1. So that integral should be set up as, I'll use the colors corresponding to that, x cubed, and then we are going to subtract the -1 here, because that's the function that is below. Okay, so that's what we want to find. Well, this is a basic definite integral that we now are experts with, so we can go through and make this calculation. So this is equal to the integral from -1 to 1 of x cubed plus 1 dx. And then the antiderivative is x to the 4th over 4 plus x. And we want to evaluate that from -1 to 1. So that's equal to, now we substitute in 1. So you'll have 1 to the 4th over 4 plus 1. All of that minus, let's make that a little bit better. So all of that minus, now you substitute in -1, so you'll have -1 to the 4th over 4. Then we're going to add a -1, or in other words, subtract 1. So that's equal to 1/4 plus 1 minus 1/4 minus 1. That's equal to 1/4 plus 1 minus 1/4, distributing negative, plus 1. The 1/4 cancel out, and you're left with 2. So that is the area. That's the yellow portion. You get 2 or your final answer. Okay, so that's what this yellow portion is. That area between all of these curves is 2. Excellent. Now let's look at another example. We want to find the area between y equals 2x squared plus 7x minus 2 and y equals -x squared plus 4x plus 4 for x in the closed interval -2 to 2. Now you may look at this problem and immediately think, oh, wow, I don't know what the graphs are for these two functions. However, you know that the shape of this function here, y equals 2x squared plus 7x minus 2, the shape of it is an upward facing parabola, right? So the shape of this one goes up. And then whenever we look at y equals negative x squared plus 4x plus 4, because it has that negative here, we know it's a downward facing parabola. So the shape of it is like so. Fill that part in. Okay? So the big question is, do these two graphs intersect? So what we have to do first is we have to find our points of intersection. So let's do that. So we have to find our points of intersection. And if you want to find where two functions intersect, you have to take them, set them equal to each other, and solve. So we have 2x squared plus 7x minus 2. That's one function. And we have to set it equal to negative x squared plus 4x plus 4. Now we have to solve it. Well, we add x squared to both sides. When you add x squared to both sides, that gives us 3x squared plus 7x minus 2 equals 4x plus 4. Remember, we added x squared to both sides. Now, we need to subtract 4x from both sides. Well, that'll give us 3x squared plus 7x minus 4x minus 2 equals 4, or 3x squared plus 3x minus 2 equals 4. Now subtract 4 from both sides, and that gives you 3x squared plus 3x minus 6 equals 0. They all have a 3 in common, so factor that out, and you're left with x squared plus x minus 2 equals 0. And then you can factor that as x plus 2 times x minus 1 equals 0. And then that means x plus 2 is 0, or you have x minus 1 is 0, which means x equals negative 2 and x equals 1. Those are your points of intersection. Okay, so now when we graph this function, we sketch the graph of it. We'll leave the space to the right to calculate the definite integral. Then we know x equals negative 2 is an intersection point, and we know x equals 1 is an intersection point. And we know by the shape of the graphs that this is the shape of this one and this is the shape of that one. So using the same color, let's go back and mark negative 1, negative 2, 1, and 2. And then we want to sketch the graph of the function. So we're going to sketch the graph of negative x squared plus 4x plus 4 first. So it's going to go through negative 1. And then it's going to look like that. And this point, if you want to find out what this point is, you substitute in 0. Substitute in 0 here. And then you'll get 4. So this point here is 4. Okay? Now, that is y equals negative x squared plus 4x plus 4. Now, we know that the graphs, meaning this one and this one, intersect at these 2 points. So now let's sketch the graph of this one. Well, we know it has to intersect here, and we know it's an upward facing parabola. So we know that at -2, that has to be an intersection point. Then we're going to go back, and our graph, if you want to know at what point it's going to cross here, you substitute in 0 for x and you get -2. So you're going to have that's -2. And remember, the two graphs intersect at -2 and 1, so we know that it's going to look something like that. Okay? Now, how do we know what's happening with our graph, or how do we know what area to find? Well, remember that our interval is from -2 to 2. So from -2 to 2. And we want to find the area in between. So we want to find this yellow portion here to here. Okay, we want to find that shaded region. So our area, let me erase that. We'll need a little bit more room. So our area, draw a line here to separate this part. So our area is going to be equal to the integral from, make a better integral symbol. It's the integral from -2 to 1. Now, let's make an observation here that whenever we're looking at this graph, notice that y equals -x squared plus 4x plus 4 is above this graph here. And just to make sure we're labeling it and we're all on the same page, the red graph is that of y equals 2x squared plus 7x plus 2. That's that graph. Now, that happens from -2 to 1. So from -2 to 1, we're going to have this integral that I'm about to write. We didn't even figure out this portion yet. So we'll have -x squared plus 4x plus 4 minus, remember, minus, and then this is the graph below, so we're going to subtract from that 2x squared plus 7x minus 2 dx. But that's only going to give us this portion of the shaded region. We also need this. Well, now notice that we're going to have to add to this the integral from 1 to 2, right? Because that's what it's bounded by on this portion, 1 to 2. And here, 2x squared plus 7x plus 2 is above this one. So we start out with this one here, and then we subtract that one. So we're going to add to this integral. We're going to add the integral from 1 to 2 of, and we're going to start out with the one on top, which is 2x squared plus 7x minus 2. And then we're going to subtract from that -x squared plus 4x plus 4 dx. If you need to, pause the video and go back through that explanation. We're not done yet. We actually have to go through and do the computation. Now, I'm going to jump a few steps. So what I want you to do is note that here, we're going to simplify this. The meaning, distribute this negative to each part and combine like terms for everything in the brackets here. Do the same here. Pause the video Do that and then come back to the recording and you'll see what we're about to do. So this area is equal to the integral from -2 to 1 of -3x squared minus 3x plus 6 dx. That's what you get when you simplify the first integral, plus the integral from 1 to 2 of 3x squared plus 3x minus 6 dx. Okay, now we find we're still doing the areas, so we find the antiderivatives of each. So we have -3x cubed over 3 minus 3x squared over 2 plus 6x evaluated from -2 to 1 plus 3x cubed over 3 plus 3x squared over 2 minus 6x evaluated from 1 to 2. Then we substitute our values in and simplify. Well, notice that cancels there and leaves you with -1. This cancels here and leaves you with 1. So whenever you substitute everything in for this first portion, you plug in the 1 and then you subtract what you get when you substitute in the 2. Whenever you do that, you are going to get -1 minus 3/2 plus 6 times 1, which is 6, minus, we're still on the first portion, we substituted in 1, this is what we got. Now we're going to substitute in -2 here, and we're going to write out what we get. Well, that's the following minus -2 cubed, but -2 cubed is -8, and you also have a negative out here already, so that's going to be -8 there, minus 6, and then you're going to have -12, and then we're going to add to that. So here, this adding portion, we're going to add to that what we get whenever we do the same for the other part, for this portion over here. So we're going to add to that. You substitute in 2 cubed is 8, and then plus 6 minus 12, and then you're going to subtract from that what you get when you substitute in 1. Well, that's 1 plus 3/2 minus 6, and when you simplify all of that, we get that that's equal to 19. So this area between the two curves turns out to be 19. That's our final answer. Great. So now what we want to do is we want to find the area that's enclosed by the line y equals x and y equals x cubed. Sketching the graph. We have our coordinate plane there. We want to sketch the graph of y equals x. That's the line y equals x. And we also want to sketch the graph of y equals x cubed. And y equals x cubed looks something like this. Okay, so that's what we have. And that's the one for y equals x cubed. That's the red one. And now we want to find this area that's bounded by those curves. So we want to find the yellow portion. Now, What are those points? Well, looks like it intersects here, here, and here. Well, we know this is the origin, but to find everything algebraically, this is what we do. To find your intersection points or your points of intersection, remember to do that, you set your equations equal to each other and you solve. Okay, so we set x cubed equal to x because they're both represent y, and that means x cubed minus x is equal to 0. Factor in x out, and you have x squared minus 1 left. You have that product is equal to 0. Well, you can factor x squared minus 1 is x plus 1 times x minus 1. That means you have the product of those three is 0. Well, that means x is 0, x plus 1 is 0, or x minus 1 is 0, which means x is 0 from the first one here, x equals -1 here, or x equals 1 here. So that means this point in our graph, this point here, that happens at x equals -1. And this happens when x is 0, and we get this one when x is 1. Okay, so those are our intersection points here. Okay, now why do we care? Because now we have to set up our definite integral, and when we do, we know that x cubed is above y equals x here, and we're integrating from -1 to 0. And then for this portion, when we're finding the yellow part or the area, we're integrating from 0 to 1, and y equals x is above y equals x cubed. So pause the video and see if you can set up the integral, and then after you set it up, come back and see if you got it correct. Okay? All right, so now to set this up, to find the area, we have the area is equal to, we're going to have the integral from -1 to 0, and then x cubed is above in this portion here, and then we are going to subtract x, and then we'll have dx here, and then we're going to add to that the other portion of the yellow region, but we're integrating from 0 to 1 here. So from 0 to 1, and now we should put x first because that's above this one. So we have x minus x cubed dx. Perfect. So now we find our antiderivative and we evaluate. Okay, so let's do it. So we get x to the 4th over 4 minus x squared over 2. So x to the 4th over 4 is the antiderivative of x cubed. X squared over 2 is the antiderivative of x. We evaluate that from -1 to 0 plus x squared over 2 minus x to the 4th over 4, evaluated from 0 to 1. And then we substitute in our values. I'm going to draw a line here to separate that. We substitute in our values here, and we get 0 minus 0, no fun. All of that minus, now you substitute in -1 in for x here. So substituting in -1, -1 to the 4th is 1. So we have 1/4 minus -1 squared is 1. So that gives you -1/2. And then this plus here, plus, now you substitute in 1. You get 1/2 minus 1/4. All of that minus 0, right? You get get 0 when you substitute in both. So distribute your negative. You get negative 1/4 plus 1/2. And then you have plus 1/2. That should have been 1/4, not 4. We can't change the problem, so make sure you make that correction. That should be 1/4 up here. So this is minus 1/4. And so that gives us that this area is 1. 1/2 plus 1/2 is 1. And then negative 1/4 minus 1/4 is minus 1/2. So we get 1/2. So it turns out that our area between the curves y equals x and y equals x cubed, this yellow portion, if you add them up, you get 1/2. That's it. Okay, that's the area between curves and applications. So make sure you review this information and work on your homework.